Hello, CP 637. So, assignment 6. We're continuing on with multiple linear regression. Now we're doing some interaction terms. And let's get started here and look at the assignment descriptions. So I uploaded a version that was recoded. There were some people that had some coding errors, and I wanted to be able to compare today in class to make sure that we're seeing things the same way. So the model is to have SES, confidence, gender, enjoyment, language, and opportunity to learn in that order. And the situation that I pose here in the assignment is, suppose there's a reason to believe that there's an interaction between gender and confidence, and you are then tasked with creating an interaction term for female and confidence. Female meaning that a 1 in this case means that a person is a female. That's why it's called female. Make sure that it's a scale variable, otherwise SPSS will not run things correctly. And then we want to test and see if the original equation is any different by adding female times confidence in there. So if we go to SPSS, first thing we need to do is create that variable. So you do that by going to transform compute variable. Then we're going to call this, I'm just going to call it female underscore confidence. And we're going to take female, put it over here, multiply times confidence. And I called it confidence 2. We're using the scaled one, so this is the one that is already dichotomized. Put it over here. And click OK. And then we see it pop down here in the bottom. And it is listed as nominal by default. That is because it recognizes there's just 1s and 0s there, so it thinks it is not a continuous variable. And then we need to run the regression. So, if you remember, the original equation was, first of all, PV1 math is here. Then we have SES. And then confidence, which is actually in this case confidence 2, the dichotomized scaled one. And then plus gender, female, plus enjoyment, plus language. And here I've called it language same because a 1 means that it's the same language. And then opportunity to learn, I called it opportunity to learn some because 1 means at least some opportunity to learn. All right, and then now we go to next. We put them in the same order. SES, confidence, female, enjoy, language, and then opportunity to learn. And then now, so these should be the same, and if you go back and forth, you don't see any changes here. And then we want to add this variable at the bottom. Now, whenever we do this, remember that now we want to also have R squared change box checked. I'm going to go ahead and select all of these. I want to see the collinearity diagnostics. Plus, it's good to keep practicing these things. Continue. And I'm not going to worry about the rest for now that we would normally look at. But let's do this and look at the output. All right, so across all the variables, we have a total sample size of 19,399. Let's look and see if this, so you can see female times confidence basically has no correlation with anything except for language and opportunity to learn. oh, sorry, I'm looking at the wrong piece. Here, never mind. We see that it has very small levels of correlation, has a moderate size correlation with confidence, which we should expect. That was one of the two things we multiplied. Has a very high level of correlation with female. Everything else looks very small, including even PV1 math, the outcome measure. So that doesn't look good. It doesn't look like it's probably going to have much of an impact. And it also looks like because it is highly correlated with female, that maybe simply female on its own is explaining things, and there's female doesn't interact with confidence much. It could be. All right. Look at the R squared. So R squared for model 1, which didn't include that term, 0.282, and it changed to 0.283. The adjusted R squared didn't change at all. So the R squared change actually is listed as 0. And yet, F changed by 11 points, resulting in a statistically significant change in the F score. So, based on the fact that we see a 0 change in R squared, I am thinking at this point that this is not a substantial improvement in the model. It does not add much. It doesn't help explain any further the differences that we see in students' math scores. Overall, ANOVAs, both models, of course, are statistically significant. If the first one was, the second one certainly should still be. If we look at the collinearity diagnostics, model number 1, no issues as expected. Model number 2, we see things approaching close to the cut values for VIF and for tolerance. Remember, VIF, 10 or greater, tolerance, 0.1 or less, and where we would expect them. So gender, the female variable, was highly correlated with female times confidence, and we see that the female variable and female times confidence are both pretty high scores, relatively speaking, and the VIF, or the tolerance scores, are quite low. But they still are not at the point where the cutoff rule goes into effect, even though that should raise some suspicion. And if we look at the actual impact of these variables, so female scored, the scores were about 8 points less than males. We know this from previous models that we've run. And confidence, 47 points for each increase in level of confidence. However, if we look down here, when we added female times confidence, the gender variable on its own essentially dropped out to 0. It became no longer statistically significant. The confidence variable actually increased a little bit. So including this female times confidence had the effect of the confidence variable on its own soaking up some of that female variable's explanation of the variance in math scores. And then the rest of that got taken up by this female times confidence variable. And the rest of these variables had very small changes, mostly at the hundredths place. So what this might be telling us is that if we could assume that female times confidence actually had a statistically significant improvement on the model, which it shows that it did, but practically speaking, I would say it doesn't. And if we look over here at the part correlation, negative 0.021, so if we square 0.021, that results in a 0.04% unique explanation of variance explained. I would say that's not practical. One thing we can take away is that it does seem that female times confidence, that females don't have much relationship with confidence. So this female times confidence variable just ends up explaining the majority of the variance that female had explained before. But because this is so low, the 0.021, it seems like most of that additional explanation of the variance in math scores actually went to the confidence variable rather than to this interaction effect. The confidence increased. And if we look at conf2 at the part correlation, it is 0.146. Confidence 2, 0.182. Actually, it went down a little bit. So that rules out what I was trying to say. But it didn't explain much to begin with, 0.042 on its own. So I would say it doesn't look like it explains much. If we go back to the instructions, respond to the following. What was the change in R squared? Basically 0. What percent additional variance is explained by the interaction effect? That's what we just looked at, around 0.04%. Was the change statistically significant? Yes. Practically significant? No. We can point to those values in the table. What does this mean in terms of the model? Should you keep it in the model? My suggestion at this point would be don't keep it in the model. It doesn't explain much. It doesn't add anything to the model, really. So we can sort of rule it as the statistical significance was just a result of a high sample size. And then looking at coefficients in the table, interpret the coefficient for the interaction effect. What is it telling you? So if we go back over here, negative 10.471. So remember that this variable gets included in the model when, or that this negative 10 points gets included in the overall model when a person is female and they are confident in solving those applied math types of tasks, or the not applied math, the basically two-step equation. So students who are female and confident actually have a decrease of about 10 points in their score over people who are not female and or not confident. And it's an or statement there. And we could draw that out, and we can do that in class today to get a better idea of that. All right, moving on. Suppose there's reason to believe there's an interaction between enjoyment and confidence. Create an interaction for enjoy times confidence, and make sure it's a scale variable. So if we go back over here, so we need enjoy times confidence. Transform compute variable. I'm going to click this reset button down here to clear all that out. I'm going to call this enjoy underscore conf. Then I'm going to put enjoy 2 over here times confidence. So maybe people who enjoy math are also confident. Click OK. Make sure to change this to scale. And then we're going to run another regression. And this time it says we're going to take out the female times confidence, and we're going to put in enjoy times confidence. We already have the statistics set for giving us R squared from the last time. Click OK. If we look at the correlations, enjoy times confidence, still a pretty low correlation with PV1 math, but much higher than the last variable. Confidence is moderate, similar to the last time, but it has an even higher correlation with enjoyment. And this is the same one that we did in class last week. You can see that it has a very small impact, 0.001, so bigger change in R squared than before, but not by much. It seems to not really be that important in the model. And if we scroll down here, we see Um, the enjoy confidence is looking very, very, very close to that cut score. That should be sending off some alarm bells. But let's look what happened when we included it. So confidence was at 47. It went to 43. And enjoyment was at 8.2. Enjoyment changed to a negative 5.2 and no longer statistically significant, which I'm not surprised because enjoy and enjoy times confidence are highly correlated with one another. Enjoy times confidence has quite a large coefficient size, an impact of 15 points on the outcome measure. Let's look at what happened to the part correlation. It still is very small, 0.027. If we square that, we get 0.07%. And remember, if you look up here, it was 0.001. Well, 0.007 is the actual part correlation that gets transferred to an R squared value. When you square it, that rounds to 0.001. So that's why you see this 0.001 here. Very, very small impact or explanation power that this one has. So even though it looks like it has some statistical significance in the change in the model, that change is extremely small, and unless you have a reason that you would want to keep it at this point, my idea would be, why are we putting it in there? We can tell some things from this, like we discussed in class before. For instance, whenever we include enjoy times confidence, enjoy becomes no longer statistically significant, indicating that people who enjoy math are also confident. So it does have some meaning in the model. It just doesn't explain very much, even though people who enjoy math and are also confident score about 15 points more on average than people who don't, who either don't enjoy math or are not confident. The interesting thing is that people who are enjoy math in this model actually have a decrease in their performance, but that decrease is not statistically significant, indicating that perhaps we should run a third model that removes the enjoy to variable and see how that changes the model and just leave in the interaction effect. Okay, back to the instructions. What was the change in R squared? What percent variance is explained? Interpret the coefficient. And there we go. All right, that is it.